Sixth grade, happy Tuesday. We're ready to get into the chapter on rocks and minerals today. Remember from yesterday we had the skill of comparing and contrasting, where you're looking at the difference between real gold and fool's gold. Fool's gold was pyrite. Today we're going to move on. Start over here with just another reference back to gold. It says gold. Dust and noise fill the cool Nevada air as gold mining trucks move tons of dirt. Searching for the precious metal is part of another's day work. Gold is too heavy to use for tools and it's too soft to be used for cutting. Yet no other mineral is as highly prized as gold. Its beauty has sparked wars, lured explorers to the New World, and made it a symbol of wealth. So what exactly is gold? So they're talking about gold, guys, and we're going to learn more and more about gold, but all those things are true. You've studied ancient history to know the power of gold. We'll continue to talk about it as we go through ancient history. It's why America was located. We were searching for the gold all over the Americas, and it's definitely still today a symbol of wealth. All right, let's get into our lesson. Today we're talking about what are rocks and minerals. The summary statement says this: each kind of mineral has its own unique chemical structure. Differences among minerals result from the way the particles of each mineral are arranged. Deep within Earth, newly formed rocks are exposed to heat and pressure. At Earth's surface, rocks are gradually broken down. So we'll start talking about that, guys. Here is pyrite. Remember, pyrite is fool's gold. Remember yesterday when we were talking about how pyrite forms in these cubes, these crystals? You can see that, how the blocks of crystals are formed. So if I see something that looks cubish, it's fool's gold. All right, let's get going and learn what a mineral is. Gold is only one of many different minerals found on Earth. What is mineral? Mineral is a first blank, natural, second blank, non-living solid that has a definite chemical structure. So guys, there's three things that it needs to be that. You need to write down two of those. It's natural, which means it's not human-made, and it's non-living, and it has a definite chemical structure. To be a mineral, a substance must meet all parts of that definition. For example, coal is not a mineral. Why? Because it was made from plants that lived long ago. So remember, guys, the difference between non-living and dead is dead, you once lived. Non-living means there's no part of you that ever lived. So coal is made from dead plants. Coal is not a mineral, guys, because it had living plants at one time. How many minerals can you name? You probably know more minerals than you think. For example, have you ever looked closely at grains of sand? If so, you were probably looking at the mineral called quartz. Earth's crust contains more than 4,000 kinds of minerals, yet only about 24 are common. So I have to do a little math for number 3 and say about how many are common. Well, 24 is 24, guys, so about 24 are common. Other minerals you might be familiar with are diamond, quartz, emerald, copper, and ruby. So number 4, it says, can you name 5 minerals? They just did it for you guys. 1, 2, 3, 4, and 5. You had a 6th one. Gold is also a mineral to be able to put in there. Gemstones such as emeralds and rubies are minerals that are valued for their beauty and their rarity. Okay, so you had number 5 in your notes, guys, the beauty of it. You also had another mineral that was named there. Emerald was not named in this first list up. Oh, I'm sorry, it was named in there. So was ruby. So it's given the 2 of these and saying its beauty and its rarity. Rarity, guys, the root word is rare. It means there's not a lot of it. Anything that there's not a lot of, the price goes way up. You think of the world's fanciest cars. I guarantee you just didn't think of a Ford truck, did you? Okay, Ford trucks are common, therefore they're cheaper. You think of fancy, super rich cars, that's because there's not very many of them. Rarity is one of the biggest things that drives up price. In ancient history, guys, we're talking about silk. Silk is rare in ancient times, therefore it's very expensive. Notice in the pictures that minerals have a geometric shape. The geometric shape is due to the way their particles are arranged. Minerals are made up of crystals. Okay, what's a crystal? Particles of crystals are arranged in a particular repeating pattern. So number 6 in your notes, that repeating pattern. This pattern is reflected in the shape of the crystal. Crystals form when minerals are made in nature. Under perfect conditions, some crystals are large. but most crystals are so small that they cannot be seen without a microscope. So you got the word large, guys, for the next ones in your notes. What they're saying is if it was perfect, we could have some sweet things. Okay, number 7 in your notes, when they're made in nature. So you're starting to see the difference when we start talking about what we call synthetic, man-made ones. So you have these things and you can see how they're trying to play out. This is crystals, guys. Okay, so I see this pyrite crystal and I go, oh, well, sure enough, there the big block is. Understand, guys, these crystals are microscopic, and I put thousands of these together and I get this block. Okay, so I don't want you to think that they're always the same shape as they go through those things. Okay, so usually small and lots of times not perfect conditions. All right, turning the page. Going too far. Here we go. Let's learn how we identify minerals. Okay, when you visit a zoo, you can identify many animals. You can use characteristics such as size, color, and shape. Minerals also can be identified according to their characteristics, or we might use the word properties. Okay, so you got characteristics for your notes, guys. Properties would be another thing that you could use to identify those. And what they're getting at is, here are some of these things. I can simply use size, color, and shape, but there's a lot better ones. Scientists use number 1, hardness and other properties to identify minerals. Okay, what's hardness? Talc, which is used in talcum powder, is a mineral. Talc is less hard than other minerals. Scientists use the Mohs hardness scale to tell the hardness of a mineral. A mineral's hardness refers to how difficult it is to scratch its surface. You have number 10 in your notes. We're talking about scratching a surface. Okay? A mineral can be scratched only by a harder mineral. The softest measure of a hardness scale is 1. The hardest is 10. Talc, boom, has a hardness of 1. Diamond is the hardest natural substance known. It has a hardness of 10. Okay, so number 11 in your notes, it goes from 1, in parentheses, you'd write the word talc, guys. That's an example of it. To 10, you'd write the word diamond. And diamond is the hardest natural substance known. It's one of the things that make diamonds so valuable. Number 1, diamonds are kind of rare. But number 2, they're valuable because they're super hard. Okay, talc, guys, this is like chalk. Okay, back in the day when I was a kid, we'd had chalk boards. You start writing with chalk, what do you see? You see the powder just falling down. That is because talc is being scratched by the chalk board. Okay, a diamond could scratch anything out there. And that's one of the ways in how we find differences apart. Okay, little known fact from kids. When you hear the word diamond, you probably instantly thought of jewelry. Most diamonds are not used in jewelry, guys. Most diamonds are used in tools. Okay, so on the top of my page for extra credit, I want to write down diamonds for, I'm going to use the word cutting. Sometimes you want to go into Menards, you'll see what they call diamond-tipped saw blades. So what they do is they take little diamonds and they melt it into the metal on the tip of a saw blade, and they'll use that to cut metal. They'll use it to cut wood, obviously, but they'll use it mainly to cut like concrete because it's so hard it cuts through those things. I can't use a normal cheap saw blade to cut through metal, but I can if it's tipped with diamonds because diamonds is the hardest thing. So lots of diamonds are used in saw blades for cutting, drilling holes in concrete, things like that. All right. One way we tell minerals apart is their hardness. That was what we'd have used to tell gold and pyrite apart. Gold I can bite, pyrite I can't. Cruising on. A mineral may also have different colors depending on the kinds of materials in its crystals. For example, pure corundum is colorless, but when its crystals contain small amounts of chromium, it forms ruby, a red gemstone. A mineral's true color can be seen in its streak. The streak is the mark it makes when rubbed against an unglazed ceramic tile. So you have number 12 in your notes, guys, and you might want to circle number 12 because this will be a question on your test. What do we have to scratch it on to get streak? It's an unglazed ceramic tile. So guys, think of the floor in your school. The floor in your school is made up of ceramic tiles, but we have them glazed. We've covered them and made them shiny. It can't be unglazed. So look at this. These 4 mineral samples may look different, but the reddish brown streak shows them that they're all the same. So this rock, this rock, this rock, and this rock are literally all the same mineral. And you would say, no, they're not. They don't look anything alike. Look at the scratch. The streak here is all the same. So they're all from the same mineral, guys. And that's what they're getting at. Just like yesterday, I would scratch pyrite on here and it would leave a greenish black mark. And I'm like, but it looks gold. What's it doing? That's why it calls its true color, guys. Just as a fingerprint can identify a crime suspect, the shape of its crystals can help identify a mineral. For example, fluorite crystals are shaped like cubes. So in number 13 in your notes, guys, the shape of its crystals. Remember, though, that this one's not easy for us because most of those you need a microscope to look under. So number 1, I have to get a small piece of it. Number 2, I have to look under a microscope to see that. So it can definitely be used. It's just not that easy for us. Minerals also show particular patterns when they are broken. Many minerals tend to split or cleave along flat planes. This splitting is called cleavage. Other minerals do not split. Instead, they fracture or break into uneven pieces. Okay, so number 14, the way minerals tend to split along flat planes. One really good rock for this is called obsidian. It's a black stone made from lava, guys, but it looks like glass, and when you crack it, it gets a sharp edge. So it has it cleaves along these flat planes, which makes them very sharp. Lots of times when you think about smashing a rock, you think about this one. It'll just break into all kinds of random little pieces, okay? Next one that we can tell it apart. Luster is the appearance of a mineral as it is reflected in light. Okay, so I have reflected light there for number 14 in my notes. And now let's talk about the different ways it can reflect light. A mineral may appear metallic or non-metallic. We might use the word greasy, glassy, or even waxy. Compare the luster of quartz with that of So you see how this way we'd say, ooh, that's glassy, and we'd say, that's not. That's, rock, that's dull. We could do glassy with a diamond. They talked about yesterday gold being buttery, and you could see this one glassy. So you can see how we different use those terms. That's luster, how light bounce off is it. Some minerals have unusual properties. For example, fluorescent minerals may show colors when viewed under ultraviolet light. A few minerals, such as magnetite, are magnetic. Okay. So 16, you have what they do under UV light, or what the word is ultraviolet light. That might cause it to shine. And you have some are magnetic. You got to give the word down for it. That's magnetite. That's cool. It'd be easy to find by running a magnet over it. Last but not least, several minerals are valuable because they are beautiful or have unique characteristics. Many of these minerals are also rare, which adds to their value. So we're trying to figure out what makes them worth more than others. Number 18, it says minerals are valuable because they are beautiful. That's your gemstones, guys. If you want another credit, you could circle the word minerals. You can see I made a capital I in there instead of a lowercase I. And then the second blank, guys, is what we talked about. They're also rare. Okay, these minerals are often important natural resources. Since natural supplies are limited, scientists often seek ways to reuse minerals or replace them with less expensive materials. For example, aluminum and tin are 2 minerals that can be recycled. Awesome. So number 19 in my notes, they can be recycled. That's cool, so I'm not using them up. Scientists can also make synthetic or artificial forms of gemstones such as diamonds, rubies, and emeralds. So you have number 20, which is the word synthetic. We need to understand that word and how it works. So can I go and have something that looks like a diamond that doesn't cost very much? You bet. Okay, that's called a cubic zirconium, is the mineral we use, which is a cheap fake diamond, guys. We can make those things because they're cheaper. Now, why have we done that? Well, not everybody can afford a big diamond, so poor Mr. Bauer wants to buy something that looks nice but doesn't cost a lot. So he gets a fake diamond, guys, a synthetic one. Now today we're learning to make diamonds. See, diamonds are formed under great heat and pressure. Today we're trying to do that in a laboratory to make those things so that they're still valuable. They're actually classified as diamonds, but they're being made synthetically. Okay. Today we do that as well with gold. We mix gold with other metals to keep the price down to do those things. Okay. 6. We're going to stop there for today. We got halfway through how we identify minerals. There's about 10 different properties or characteristics on this page that we use to help ourselves out with it. We'll see you tomorrow as we finish up lesson 1.